right, ladies and gentlemen, welcome to part 2 of the line best fit and correlation coefficient lesson. So yesterday we talked about what line of best fit is. It's a line that models the data. So it can go positive, it can go, have a positive slope, it can have a negative slope. Sometimes lines aren't good fits for the data. But then we talked about how to get the line of best fit using a calculator. You got your online calculators, you got your graphing calculators, either one. What we're going to do is work on the next 2 blanks, and that requires you to know a few things. The first thing is knowing about this correlation coefficient R. And what does it mean? Well, here's some information you need to know. The correlation coefficient is a number between -1 and +1. It is never something like 1.8. Correlation coefficient's never 98.7. It's never above 1. It's never below -1. It's always between those. And so it's always going to be 0 point something. And the closer that number is to 1 or -1, it's said to have a higher correlation. And so something like a correlation of 0.9 has a very distinct pattern, right? The points are following that positive trend very closely, and you're looking at a really strong correlations like 0.8, 0.9, 0.99. The reason I had you guys not round to 1 on a correlation coefficient is because if your correlation coefficient is 1, that means all the points are on the same line. Like there are no points off of the line. And the same thing with a correlation coefficient of -1. Correlation coefficient is positive if the slope is positive, and then it's negative if the slope is negative. But whether it's positive or negative doesn't tell you whether it's strong or weak. It just tells you which direction things are going. But yeah, the closer to 0 means it's going to be more scattered. I'm going to write this out with words, So scattered is closer to 0. Something like this, right? Correlation coefficient of 0 or like 0.04. Those are really low. And so something like 0.8, 0.9. These are really high correlation coefficients. Something like 0.5, 0.6, 0.7. Those are kind of moderate. And then things that are less than 0.5, things like 0.1, 0.1, 0.2, 0.3, those are said to be really low or weak correlations. And so on your assignment, you already got a bunch of correlation coefficients, and we're going to have you kind of write about like how good is the correlation between those 2 variables. And we're going to look at a few examples of like what things look like visually first so you can kind of see it. Here's some other correlation coefficients, right? Something like 0.7. It's going to look like this. It's a little scattered, but it does have that upward trend there, staying pretty close, right? Something like 0.3, those dots kind of look like they're all over the place. Like they are going up in general, but it's not great. Here's another example where these are the negative versions of it, right? It has a trend, but it's not that great. This one, the trend is a lot more pronounced, right? As you go right, these things are pretty close to your line of best fit. So that's why like 0.7, 0.8, 0.9, those are stronger correlations. And then as you get closer to 0, like 0.3, or actually at 0, your correlation just disappears. You can't see it. And so that's something to keep in mind. Here's a few more. Something like this would be -0.9. Again, really strong, following that pattern. Positive 0.9, really strong there. Something like positive 0.5. Again, spread out, but does have an upward trend. Things like 0, they're just all over the place. And then it's only 1 if they're all on the same line. If any of them's not on the line, you can't say it's 1 anymore. And so let's go, we're going to skip a few things. Let's get to the actual assignment. So yesterday we got the line of best fit for number 1 on there, and we're going to do the next 2 parts there. So this one here, what does the correlation coefficient tell you about the data in this problem? Well, we have a correlation coefficient of 0.76, which is pretty good. That's a strong correlation coefficient. And so what that tells us is meal cost and tip have a strong correlation. And so we're going to write that down. Meal costs and tip have a strong correlation. Correlation. I should spell right. And that's all you need to put, like, the two variables there, right, meal cost and tip, have a strong correlation, which would mean that generally as the meal cost goes up, the tip also goes up. And that's a general trend. The next blank that you need to do on all your problems is going to give you a problem where you have to use your line of best fit to solve it. And so we already got our line of best fit. It's up here. I copied it down here for ease of use. But it gives you a problem, right? If the next dinner costs $10.50, how much tip would the waiter expect to receive? Well, you need to know where this $10.50 goes in our equation. We're going to plug it in and solve for the other variable. So meal cost is $10.50. Is that an x or a y value? Well, that's going to be an x value, right? We said this first row is our x's, so meal cost is going to be $10.50 is going to be our x value. So we're going to plug that in, and we're going to use the magic of mathematics to simplify this. You just put that in your calculator, or you can do it by hand, which would be a huge pain. But yeah, go ahead and take a moment to put in your calculator and get what the tip y value is going to be if x is $10.50. Pause the video, get it done. Alright, I got $1.68. So there we go. You'd expect $1.68 tip for someone who ordered a meal of $10.50. And let's do one more. On number 2, again, you should already have your line of best fit and your correlation coefficient, and see if you can fill this stuff in, and we'll go from there. All right, let's have you check and see how things went. So yeah, this correlation coefficient, 0.78, that's a pretty strong correlation coefficient. I wouldn't say it's like really strong. It's kind of a moderately strong, so I guess you can say moderately strongly correlated. You know, a correlation like 0.9 is very strong. You know, as you start going down, things get, less strong, obviously. You can kind of think of this as like your percent on a test. Let's say you got 78% correct. It's good. It's not terrible, but it's not like the best thing you can ever have. Whereas, if you got 50% right on a test, you would say that's not that great. And so that's a lot weaker correlation. Anyway, on this next part, predict the exam grade for someone who studied for 6 hours. X represents hours studied, and so this is going to be x equals 6. You're going to plug it in. You're left with a line of best fit up here, and compute, and you get 108.08, which you may have noticed is above 100%. Well, that's the kind of one of the failings of line of best fit. Is sometimes when you go outside your data set, you kind of get answers that are outside of what reality has, right? This may have hit the ceiling for the max grade you can get, but the line itself doesn't know that because it's a line. It just goes on forever and doesn't care. And so, kind of keep that in mind. This is the prediction according to the line, so put that. But if you notice it was above 100%, congratulations. Or maybe this test actually goes to 200 and everyone did really, really, really poorly. Anyway, that's kind of the idea of what's going on there. Use your line of best to answer a question. Know what the correlation coefficient number means about the data, and have a wonderful time finishing up your assignment.